In this demo, we'll have a look at a brand new feature that comes with Cojac, a free tool for Java. You may already know that thanks to Cojac, you have a means of signaling overflows and many other things in Java code. But it's now time to climb over Java arithmetic capabilities in much smarter ways. You know, what Java gives you to simulate real numbers amounts to two kinds of floating point numbers, float and double. And as in any other programming language, those number types are terribly poor. Okay, they have a small memory footprint and are quite efficient, but having a small size and doing things in a hurry might be only a limited view of the paradise. With Cojac, you write your code with floats and doubles as you are used to. But then at runtime, you will be nearly almighty. When executing your program, you are free to choose another, richer number type for your computations. This automatic, on-the-fly number replacement really opens new perspectives that we are going to sketch with the following simple example. Say in your project you have to compute a certain polynomial. You write a naive implementation like this. On this first run, okay, the result is correct. Now let's try to evaluate the function at another point. What you get is a huge negative number, whereas I can tell you that the true result is approximately -0.8, less than 1 instead of millions of billions. Ouch! Shame on computers. Well, if you are a smart developer, you might know that there is a numerical sniffer tool that is able to signal when anomalies happen during computations. Cool! Getting warnings is far better, but this information is still a bit poor. Smearing or cancellation is not always catastrophic, and we still don't know how far from truth we are with the final result. So here comes the magical Cojac enriching wrapper. We ask Cojac to run our program using interval computation instead of primitive doubles. Now we are told that our final result has a huge uncertainty, as the corresponding interval spans 40 orders of magnitude, and even the sign of the result is uncertain. By the way, it doesn't complain with our first invocation that gave a correct result. But wait! Cojac can do better than just explaining that your result is garbage. It can compute more accurately if you politely ask to. Here is how you tell Cojac to use high-precision decimal numbers with 40 significant digits instead of the 16 ones from the double type. And what you get is now a very reasonable approximation of the exact result. Once you have richer number types at your disposal, you can leverage your existing code in even smarter ways. What if your boss now tells you that he also needs the derivative in x of that polynomial? No need to dig into the implementation of the function or a math textbook. Just take advantage of what is called automatic differentiation. You add up a couple of lines and tell Cojac to use automatic differentiation. And you're served. It is just as easy if you want to differentiate in y instead of x. AutoDiff is an awesome idea, and we claim no other tool lets you experiment it with that level of simplicity. That's it. Honestly, we don't know if our tool, which still has some limitations, can have any impact on the software industry. But for sure, we find it cool to play with it. Just for fun, see how the official Java 2D demo behaves when we ask to compute with only 2 digits. The clock gets a bit distorted, for instance. Now, dear, it's your turn. Please have a look at the user guide, download the jar, and start playing with Cojac, the coolest enriching wrapper for Java. Don't forget to give us feedback.